I guess, am I audible? I guess the audience, I feel I'm audible to all of you. Yes, we will start now. We will start. Yes, I guess it is very audible to everyone. Am I audible? Yes. So now from the CBSE 10th standard board examination, we will see what is the question paper and how to write the answers. All right. So we can start one by one question and how to write the answer in the board examinations we are studying now. So let's take it about one of a previous paper. In this paper, what kind of physics questions they have given and how to write the answers. This is the most important, how to write the answers. Now you can see there are 1 mark questions. There are 1 mark questions. Question number 3. Yes, we can identify now. Where are the physics questions and how to write the answers. All right. Yeah, just I'll give the screen share to write the answers. Yes. Now let me see what are all the questions and how to write the answers. Question number 3 related to physics. What is the question they have given? Yes, the two resistance 20 ohms and 40 ohms are connected in parallel in a circuit. How does the current passing through the two resistors compare? The resistors R1 is equal to 20 ohms and R2 is equal to 40 ohms. How they connected? They connected in parallel circuit. So parallel in the sense of all one ends at one terminal, all the other ends at other terminal. We can call it as parallel circuit. Now here they didn't give any voltage. Yes, voltage is same. If R1, R2 resistors are in the parallel, voltage will be same. Now what we need? Current we need. According to Ohm's law, V is equal to IR. So from that I is equal to V by R. What they're asking? How does the current passing through the two resistors compare? So I1 by I2 is equal to R2 by R1. I1 by I2 is equal to R2 by R1. R2 how much? 40 by 20. So it is 2:1. The current in the ratio of 2:1 is the answer. Yes. Next question. We will see the next question how to write it. The next question here. Question number 9. This is 2 marks question. 2 marks question how to answer. Let's say this question. Now state the factors on which the resistance of a cylindrical conductor depends. How will the resistance of a conductor change if it is stretched so that its length is doubled? State the factors on which the resistance of a cylindrical conductor depends. So the resistance depends upon the material medium. It depends on the material medium. And the resistance depends upon the length of a conducting wire. And the resistance is inversely proportional to cross-section area. All right. How will the resistance of a conductor change if it is stretched so that the length is doubled? Once length is doubled, the resistance will be double. Once length is doubled, its resistance also doubled. Why? Because R is directly proportional to L to L, and the sense of resistance also will be 2R. Next, 10th question. In an experiment to study the relationship between the potential difference across the resistance and the current through it, a student recorded the following observations. Potential difference, current. Potential difference 2, 3, 4.5, 5, 6 they are given. Current they are given 0.08, 0.12, 0.15, 0.20 and 0.24 they are given the numbers. Find in which one of the above sets reading in trend is different from others must be rejected. Calculate the mean value of resistance based on the remaining readings. Now V and I value they have given. So each and every 5 students resistance value we can able to calculate. So the resistance 1 is equal to R is equal to V by I. We know that. So V value 2 by 0.08. 0.08 in the sense of 8 by 100. 2 by 8 by 100 we can write. So 200 by 8. Yes, still very slowly you can simplify, that is 100 by 4. 100 by 4 in the sense of still 50 by 2, which is 25 ohms. We got it. Next, R2, second student resistance, that is again V by I, which is 3 by 0.12, which is 300 by 12. Alright, so 300 ja and 3 4 ja, again almost like 25 ohms we got it. Next, resistance R3, which is 4.5 by 0.15. Here 15 by 100, so 450 by 15, approximately that is 30 ohms we got it. Next, R4 again 5 by 0.2, which means 50 by 2 is equal to 25 ohms. Again R5 is equal to 6 by 0.24. 6 by 0.24, which means 600 by 24. That is 25 ohms. Now, first student, second student, fourth student and fifth student, they got the 25 ohms of the resistance. The third student, he got that different value. So the third student, he got the different value. Yes or no? So we have to neglect this. R3 resistance of this, which is different. Now what they're asking? Calculate the mean value of resistance of a resistor based on the remaining sets of readings. So remaining sets of the readings, what it is? R1 plus R2 plus R4 plus R5 by 4 we need to do. Approximately that is 25 plus 25 plus 25 ohms plus 25 ohms by 4, approximately that is 25 ohms. Clear? Next. So this is for 2 marks. Next, what is solenoid? Draw the pattern of a magnetic field lines of a solenoid through which a steady current flows. So what is solenoid? How to write the answer? Solenoid. Put heading of solenoid. What is solenoid? A number of turns. A number of turns with same radius. With same radius called as solenoid. Number of turns of a conductor. of a conductor with same radius is called solenoid. So draw the magnetic field lines. Now take a current carrying conductor having n number of loops with the same radius. Okay. Now these two ends you connect it. Plus minus. Current is flowing. One end to another end. One end to another end which is flowing. And the downward direction like this, which is quite opposite. Yes. Now the top of the wires, top and down, there is a loop lines. And through the axial, there is a straight line. Let's say this is a north and south. Current direction from north pole to south pole. And through the axial south pole to north pole, we need to give the arrow marks. So for this, they'll give 2 marks. Next question. Next question. Only physics we are solving from the old papers. So the next question will be 17th question, 3 marks question. Define electric current and state its SI unit. With help of a Ohm's law, explain meaning of 1 ohm resistance. So define electric current. So write down the heading of electric current. Electric current. So how to define electric current? The flow of charged particles. The flow of charged particles in unit time. In unit time called as electric current. So I is equal to Q by T. I is equal to Q by T. SI units of electric current. SI unit of electric current is ampere. Ampere. So with help of Ohm's law, explain 1 ohm resistance. According to Ohm's law, V is equal to IR. So R is equal to V by I. That's equal to 1 volt by 1 ampere. So 1 ohm we can define as 1 volt by 1 ampere. Alright. Next. The rating of an electric heater is 1100 watt and 220 volts. Calculate its resistance when it operates at 220 volts. Also, calculate the energy consumed in kilowatt hour in the month of November if the heater is used daily for 4 hours at the rated voltage. Now this is for 3 marks in numerical. The rating of electric heater power P is equal to 1100 watt and voltage they have given 220 volts. Calculate its resistance they are asking. Calculate its resistance when it operates at 220 volt. Resistance is how much? And at the same time calculate the energy consumed in the month of November. In the month of November, that is 30 days. Okay. And per day how much? 4 hours. So 30 days into 4 hours, which is 120 hours the geyser worked. Now first what we need to do, resistance we have to calculate. As you know that P is equal to V into I. So according to Ohm's law, I is equal to V by R. So once you can substitute over here, P is equal to V into V by R, which is V square by R. Power P is equal to V square by R. R is equal to V square by P. So V square value how much? 220. 220 into 220 by power value how much? 1100 watts. So 2 zeros will be cancelled and 11 twos are, which is 44 ohms is the resistance. Now H value we have to find out. Now here I am writing H is equal to I square RT, or H is equal to P into T directly. So power P how much? 1100 into time value 120 hours. Alright. Watt hours. So 132,000 watt hours, we can write 132 kilowatt hour is the heat energy. So this is for 3 marks. Next question. Only related physics we are solving according to our 23-24 curriculum of CBSE. Next, there is the 5 marks question. Describe in short an activity, demonstrate the pattern of magnetic field lines around a straight current carrying conductor. Second question, find the direction of magnetic field produced for a given direction of a current in the conductor. Name and state the rule to find the direction of magnetic field associated with a current carrying conductor. Apply this rule to determine the direction of magnetic field inside and outside a current carrying loop line horizontally on the table. Assume that the current through the loop in anti-clockwise. So this is the question they have given. So there is a 5 marks question. So we need to write very neatly, point wise, what they ask the question. Describe short an activity to demonstrate the pattern of magnetic field lines around the current carrying conductor in a straight line. Straight current carrying conductor demonstration pattern they are asking. Now probably that is for 2 marks. Let's say they catered. Now immediately we have to draw the diagram. We have taken a cardboard sheet, placed a hole and insert the copper wire. Then both the ends of the copper wire we have connected to battery terminals. Let's say current is flowing from negative terminal to positive terminal. Okay, negative terminal to positive terminal. Now, according to Maxwell right hand thumb rule, yes, what Maxwell right hand thumb rule will say? We placed thumb finger along to the current direction, remaining four-fold fingers will give the magnetic field direction. So this they are asking for the first question. Second one, find the direction of a magnetic field produced for a given direction of a current in the conductor. Name and state the rule find the magnetic associated with the current carrying conductor. Apply the rule to determine the direction of magnetic field inside and outside the current carrying circular loop also they are asking. Now the first question, yes, we written. Second question, they are asking about the Maxwell right hand thumb rule. As stated, place the thumb finger along to the current direction. Remaining four-fold fingers will give the magnetic field direction. Now there is a circular loop. Next question they are asking about circular loop. Here what happens? In a circular loop, yes, here the current direction is changing. Left hand side top direction, right hand side down direction, but the same wire. Now apply the Maxwell right hand thumb rule on left hand side. Okay, so thumb finger we placed on the current direction, remaining four-fold fingers will give that anti-clockwise direction. Now the thumb finger we are placing downwards, remaining four-fold fingers will give that clockwise direction. So what we understood, if current direction changes, magnetic field direction also will be change. So this we are projecting for this 5 marks question. Or next question you can see that. If you feel that yes, 5 marks question is a very lengthy and it will take some long time, and the second question it takes not hardly 3 minutes time, so we can save the time to attempt our question. So in our question what they given, current time direction, there is a straight line over here and here there is like a wave. In that first question, name the type of current in the two cases. First case, type of current is DC current. DC current, what happened? In DC current, in the sense of direct current don't have any frequency, so which is a straight line. And B, this diagram will give that AC current. AC current in the sense of alternating current, which will be up and down of the x-axis. So name the type of a current in two cases. First case DC current, second case AC current. So here 1 mark will get it. Identify any one of the source for each type of current. So DC current having that DC current source is battery. Normally batteries. Okay. Now AC current. AC current source will be generator. This is for generator. If the student tried this answer, he will carry 1 mark again for this question. What is the frequency of the current in each case in our country? The frequency generally F is equal to 50 Hz. Whenever we are purchasing washing machines or iron boxes, you can notice that entire the country, all electrical appliances will be 50 Hz. Next, on the basis of these graphs, list the difference between the two currents. The first difference is current direction along through x-axis, and here current direction will be positive and negative. Positive current and a negative current will be on AC current. And second difference is in DC current there is no frequency. DC current don't have any frequency. But AC current having frequency. So that frequency itself 50 Hz enter the country. Next, out of two, which one used in transmitting electrical power long distances and why? Yes, once you can see in our electrical lines, all are the AC circuits. AC current will be flow from one state to another state with a long wires, which is very easy to identify that. So that's the reason the long distance it will be carry. Next question we will see that. Next question where it is only physics we are solving from the paper. Yes. Now there are some MCQs in physics, we can see that. First 26, 27, 28, 29, 30. Yes, 31 question. You can see that how to answer this question. An ammeter can measure current up to 500 milliamperes. An ammeter can measure current up to 500 milliamperes. 500 milliamperes, that is current. There are 20 equal division between 0 to 100 milliamperes. There are 20 equal divisions. 20 equal divisions between 0 to 100 milliamperes. Okay. So during the experiment, to determine the equivalent resistance of the two resistors joined in parallel. Okay. A student observed ammeter's pointer at the third graduation mark. Now let's say there is 20 equal distances between 0 to 100. So which is 0, 5, 10, 15, like that up to 100. So 20 into 5 is 100. So 20 equal marks we can able to place. During an experiment to determine the equivalent resistance of two resistors joined in parallel, a student observed ammeter point of third graduation mark. So the third graduation mark in the sense of probably that is 15. Okay. So 15 is the third graduation mark after 0. And when the key is off and the pointer is 17th graduation mark after 200 milliamperes. When the key is inserted into the plug, the correct value of the current flowing in a circuit are. Now we need to calculate least count. What is least count? Least count in the sense of the minimum value how much we can able to count it. So the ammeter can measure up to 500 milliamperes. So 0 to 500 milliamperes. There are 20 equal parts. So 500 by 20 approximately. So 25 each. So 25 milliampere. And next one is next to 25, 50, next 75, something which will be there. Now the third graduation mark is 75 milliamperes. Third graduation mark will be 75 milliamperes. During an experiment to determine the equivalent resistance of the two resistors joined in a parallel, a student observed ammeter's point of a third graduation mark. Okay? And after 0, when the key is off and the pointer is at 17th graduation mark after 200 milliamperes. After 200 milliamperes, that is 17th graduation mark, which means 200 plus 75. No, not 200 plus 75. This is for 75 and they said 17th graduation. Before that is third graduation mark after 0. So which is over here, which is at 75. Okay, there are something like error in this ammeter. Now when the key is off and the pointer is at 17th graduation mark after 200 milliamperes. After 200 milliamperes, the 17th graduation mark. So 200 plus 17, which is 217 is the answer now. Next question. If a student while studying the dependence of current on the potential difference keeps the circuit closed for a long time to measure the current and potential difference, then option A, ammeter's zero error will be changed. Option B, ammeter will give more reading. Option C, voltmeter will show the constantly lighter reading. Option D, resistor will get heated up and its value will change. If a student while studying the dependence of current on the potential difference keeps the circuit closed, which means he is doing that Ohm's law experiment. Yes, after a long time to measure the current and the potential difference, ammeter's zero error will change. Option B, ammeter will give more reading. Option C, voltmeter will show constantly higher reading. And option C, resistor will get heated up and its value will be changed. What happens if while doing the Ohm's law experiment, if you keep on switch on both the ammeter and the voltmeter, so obviously it will be heat up. The values will be changed. The length of a wire will be changed. The resistance will be changed. So the resistance will be get heated up and value will be changed. That is the fourth option. Next question. The current flowing through the resistor connected in a circuit and the potential difference developed across its end are shown in a diagram. The approximate value of the resistor is, as you know that R is equal to V by I. According to Ohm's law, R is equal to V by I. Now on the voltmeter, what is the reading over here? On the voltmeter, what is the reading? So 1.5, 1.678. So V value will be 1.8 volt. Okay, that is directly volts. Now coming to amperes. Here how much reading it is? 150 milliampere. So current I value 150 milliampere, which means so 150 into 10 power of minus 3 amperes, because we have to convert into amperes. Now the resistance R is equal to V by I. So R is equal to 1.8 by 150 into 10 to the power of minus 3, which is 1.8 into 10 cube by 150. Alright. So while solving this approximately, No, approximately 12 will comes over here. So there are likely options are different because they given here 1.5, 6, 7, 8 if you consider. Yes, then only it is possible. Here exactly which is showing 150, but the options here little different they given. Don't worry, nearby value we can able to place it. So we can ask any nearby values. Next one. Next question. The voltmeter, ammeter and the two resistors in a circuit have been checked and found correct. On inserting the key in a plug, the voltmeter reads a 3 volt. Voltmeter reads 3 volt, but the ammeter reads 150 milliamperes. This could most likely be because the connecting wires joined. Now there are resistances 50 ohms, 15 ohms and 20 ohms. We connected in a parallel to the voltmeter. Then place minus and close a switch and ammeter we have connected. Now 20 ohms and 15 ohms are in a parallel. How much? On inserting the key in the plug, the voltmeter reads a 3 volt. So voltmeter reading is 3 volt. What they're asking? Yes, ammeters are loose, 15 ohms resistor are loose, 20 ohms resistor are loose, voltmeter are loose. So this kind of question again read properly. The voltmeter, ammeter and the two resistors are in a circuit have been checked and found correct. Yes, all you connected into very properly. On inserting the key in the plug, the voltmeter reads 3 volt, but ammeter reads 150 milliamperes. So current value through ammeter we can able to measure it, that is 150 milliamperes. Now this could mostly likely because of connecting wires jointed. Now you can see these two are in the parallel connection. Can we able to calculate the total resultant resistance? Yes, we can able to calculate. Finally, what we can get? Ammeter are loose, 15 ohms resistor are in loose, 20 ohms resistor are loose, and voltmeter are loose. One is 3 volt, other one is 150 milliamperes. What is the resistance over here? R is equal to V by I, which is equal to 3 by 150 milliamperes. Let it be milliohms later. So 1 by 50. So 0.02 ohms approximately. What is the total resultant resistance? 1 by R is equal to 1 by 15 plus 1 by 20, which is 20 plus 45 by 300. Okay, so which is 65 by 300. So R is equal to 300 by 65 ohms. So here the resistances both are in correct position only, but here the ammeter where it is going that more value, that is under the loose. So that way we need to identify. Next, yes, in this experiment on finding the equivalent resistance of two resistors 15 ohms and 20 ohms joined in a parallel 3 circuit diagrams X, Y, Z are available. For getting the result, you would choose. So what it is? So voltmeter, both the resistors are in parallel. Yes, voltmeter we have connected. It's series ammeter, battery, and this we connected. Here what we did? Battery, right side ammeter, left side switch. And you connected over here like this parallelly, and voltmeter we connected, that is why. But here ammeter and switch, and between the two resistors 1 voltmeter we got it. Okay, yeah. Now in this case what happens? Here we no need to connect between up and down over here. This is the correct, X and Y is the correct. But Z, why it is wrong? Yes, obviously this is also correct. Any one of the three is fine because we connected in parallel only. Next. Yeah. So this is the questions in a paper, and we will see in that next classes, or we can see some other question paper. In this question paper, what kind of questions we will see that. Yes, the third question. What is electrical resistivity? What is electrical resistivity? Resistivity rho is equal to Ra by L. Resistivity rho is equal to Ra by L. In a series electrical circuit comprising a resistor made up of a metallic wire, the ammeter reads 5 ampere. The reading of ammeter decreases to half the length of its double. Why? What happens once the length is decreased, resistance also will be decreased. Once resistance decreases, what happens? V is equal to I into R. The reading of ammeter decreased by half. Next. Any other 3 marks questions? We will see that. Yeah. State Ohm's law. How can it be verified experimentally? How it hold good under all conditions? Comment. So this question you can see. What is Ohm's law? The relation between electric current, electric potential and resistance, we can call it as Ohm's law, IVR. Now take a battery to closer switch to ammeter. So ammeter across variable resistor across voltmeter, and again the fixed resistor closed over here. Now once batteries are increased, electric current will be increased at room temperature. At room temperature, V is equal to IR. So this is Ohm's law. And how can it be verified experimentally? Yes, this is the verification. Now, does it hold good under all conditions? Yes, at the room temperature which is applicable. So this Ohm's law experiment we are writing over here. Next. Why does a current carrying conductor kept in a magnetic field experiences a force? Now the force concept what we studied, there is a current carrying conductor we suspended freely to retard stand. When we connected this battery, current will flows. Yes, once current flows through the conducting wire, yes, magnetic field will be involved. Now apply the Maxwell right hand thumb rule. Thumb finger we are placing along to the current direction. Remaining 4 fingers will give the magnetic field direction. Now we have placed horseshoe magnet. Once if you place horseshoe magnet, what happens? Automatically magnetic conduction will be start. So it will be oscillate. Alright. So once if it is oscillate, yes, due to the force, this iron rod is shifting. For that, we are using Fleming's left hand rule. Fleming's left hand rule. According to Fleming's left hand rule, we are placing the center finger along to the current direction, index finger along to the magnetic field direction, thumb finger along to force direction. So we have to place our center finger along to the current direction, and the index finger will indicate the magnetic field direction, and the thumb finger will indicate force direction. So this concept we are writing for 3 mark. Alright. Next. Swati draws magnetic field lines of a field close to the axis of current carrying circular loop. As she moves away from the center of a circular loop, she observes that lines keep diverting. How will you explain in her observation? Write two properties of magnetic field lines. Now, you can take a cardboard sheet. Before also we have discussed. Take the two holes over here. Current carrying conductor you have placed and connected to battery. Now current is flowing from one direction to another direction. Fine. Here you can see near to the wire magnetic field lines are very closer. Once if you far away from this wire, yes, of course, the magnetic field strength will be decrease. Magnetic field length will be decrease. Between the two wires, if gap is very more, then magnetic field lines are very weak. So this diagram and the explanation we are writing for 3 marks question. I hope this is the clear picture how to write the answers, and the students no need to write the more lengthy of answers. Marks may not be carry. How much question they asked, that much is sufficient to answer this. Probably we'll meet in that next live session. Thank you everyone.